This is the tutorial for Chapter 10, Section 4, titled Solving Radical Equations. And so let's take a look at our first problem. It says to solve each radical equation, we have to check our solution. So the first thing I'm going to end up doing is isolating the term with the radical sign. So I'm going to end up add the 3 to both sides, and that leaves me with the square root of 2t equals 14. So to get rid of a radical sign, we undo it by squaring both sides, and that's going to cancel out the radical sign, leave me with 2t equals, and then squaring this number gives me 196. And so from this point here, all I have to do is divide by 2 and then find out what half of this number is. So half of 19 is going to end up being 9. 2 goes into, I'll just set it up this way, 2 goes into 19 we have 9 times with 1 left over, and goes into 16 8 times. So that tells me t equals 98. So I want to check that solution, see if it's right. So what I'm going to do is I'm going to take that 98, substitute it back in for t, and see if it works out. So I do the square root of 2 times by 98, and then minus 3, and I should end up with 11. So doubling this answer gives me 196. The square root of 196 is 14. 14 minus 3 is 11. So since the numbers do check out, yes, that is the correct answer. So over here, this is already isolated. So I just square both sides, and so that will leave me with the 3t minus 2 equals 25. So from this point, I just add the 2 to both sides. That leaves me with 3t equals 27, and then I divide by 3. And so when I do that division, I'm left with t equals 9. So I go ahead and substitute that back in just to check my answer, see if I did it right. So 3 times by 9 minus 2. So that makes 27 minus 2 makes 25. And the square root of 25 is 5. So yes, it checks out. And the other reason why we want to be checking these answers is that whenever you're squaring something on both sides, multiplying by something, you end up, or taking the square root of something, there are chances that your answer may not match. And so we'll see that situation in other problems later on in the lesson. So let's take a look at this next one here. On this problem, what they're asking me to do is, it says you decide to install a rope swing at the bend of a river, and the time t in seconds for the rope swing to make one swing is given by this equation here, where L is the length of the rope swing in feet. And if the one swing takes 3.5 seconds, how long is the rope swing? So we don't know what L is, but I do know that 3.5 seconds is the length of time, and this expression represents the length of time. So what I'm going to end up doing is I'm going to set the 3.5 seconds equal to 2 times by the square root of L over 3.3. This radical sign goes all the way down there. And from that point, I'm going to divide by 2 on both sides. So when I take half of 3.5, that's going to leave me with 7/4. And 7/4 equals the square root of L over 3.3. So from this point, I need to get rid of the radical sign because I have nothing else attached to it. So I'm squaring both the top and the bottom of this fraction. It leaves me with 49 over 16, and this equals L over 3.3. So from this point, all I have to do is multiply the 3.3 by the 49, and then I'll do 16 times L. So I'll cross multiply here, and so I'll do 3.3 times 49, and when I multiply those numbers, I got 161 7/10. Over here, I go ahead and multiply L by 16, makes 16L. Dividing by 16 gives us our answer. So it looks like the rope swing needs to be about 10.1 feet. And that's rounded to the nearest tenth of a foot. So in the next problem, it says the radius of a sphere is given by this equation, where SA represents the sphere's surface area. If the sphere has a surface area of 131 inches squared, what is the length of the radius? Use 3.14 for pi. So we're trying to find the length of the radius and just substituting the numbers in. So 531 over 4 times by 3.14. So we do the work. So we go ahead and multiply the 3.14 by 4, divide by the 531. Let's go ahead and set up the calculator here. So we'll take the 531 and I'm going to divide that by the product. So I'm going to make sure I get the product done in there first. 4 times by 3.14, and then close the parenthesis, and see up here it's showing the order of operation it's doing, and that gives me this number, so 42.27. So go ahead and write that number down. So I've got r equals the square root of that 42.27, but the number keeps on going, so I'll just draw some dots there. Now I'm going to take the square root of this answer, so I'll use the radical sign right here, and it's taking the square root of this. There it is, 6.5. And so we're supposed to round to the nearest hundredth of an inch. So 6.502, I think the number was. Let's see, yes, 2. So the 2 is not big enough to round that up, so we're just going to leave this as 6.50, and these are inches. So it says the distance d in feet that it takes an automobile to stop if it is traveling s miles per hour is given by this equation. So here they don't have the vinculum, but the vinculum goes over both terms if it's right next to it, and that's what happens unless it tells us different. So typically if it didn't, the d would be out in front of the radical sign. And then it says find the distance it would take the automobile traveling 60 miles an hour to stop. So we don't know that distance, but we do know that speed of this automobile. 60 miles an hour equals the square root of 21d. So I'm going to square both sides. It's going to cancel out the radical sign, leaving me with 36 with 2 zeros equals 21d. So I divide by 21, and that'll give us our answer. So when I do that division, we end up getting 171.4 feet. Quite a distance it takes for that automobile to stop. So let's take a look at the last type of problem. On these ones, again, they're going to say to solve, but then also check the solutions. It's real important to check the solutions on these problems because there'll be some that are extraneous, some that do not make sense. So let's go ahead and square both sides to cancel out the radical sign since we've got nothing added or subtracted or multiplied or divided by it. And I've got a squared plus 20 equals 9a. So I go ahead and move the 9a back to the left-hand side, leaves me with that a squared minus 9a plus 20a. So I put it in descending order from highest exponent down to the lowest. So I'll go ahead and factor, and this factors to an a minus 5 and an a minus 4. And this all equals 0. And so when I go ahead and solve, I end up with two answers. A equals 5 and 4. Let's see how I got one of those answers. A minus 5 equals 0. You have to add 5 to both sides. That's why they're both positive, because you have to do an opposite operation. Before I box this, let's just check and see if it works. So I substitute those numbers in there. So I have a squared. I'm going to put the 5 in there first. So 25 plus 20. And I'll take the square root. And I should get the same thing over here. So 9 times by 5 should give me 45. So the radical of 45 equals the square root of 45. Yes, that one checks out. So I know 5 is a good answer. I'll put 4 in there now as well. So 4 squared plus 20. So it makes 16 and 20 make 36. And I want the radical of that. And then 9 times by 4 also makes 36. And those are the same. So yes, both of them are good answers in this case. Let's take a look at this one. So on this problem, I have to square both sides. And when I do that, I'm left with an m squared equals negative 6m plus 7. I do the same thing as I had done before. I'm going to move these two terms over. So I'm doing opposite operations to bring those over. And then I go ahead and factor. So this factors to an m minus, or actually plus 7, and an m minus 1. And then I go ahead and use the zero product property, and it gives me m equals negative 7 and 1. So from this point, I need to check my solutions. And when I plug in the negative 7 in for m, I end up having something that's interesting here. You see, negative 6 times negative 7 makes negative 40, or positive 42 plus 7 makes 49. And you see the square root of 49 cannot equal a negative. And so that's an extraneous So you have an extraneous solution here, one that does not make sense. We're not going to use that as a possible answer. Let's check 1 and make sure that one works. So 1 equals the square root of negative 6 times 1 plus 7. Yes, this one works. This makes negative 6 and 7 make 1. Square root of 1 is 1. Yes, so this one is a good answer. So 1 is a good answer. The negative 7 was not. So let's take a look at this next one. I'm going to square both parts here. And when I do that, I'm going to be left with a y squared over 4. On this side, I've got negative 5y plus 24 over 4. So I can go ahead and get rid of this, moving this term over to the other side. I'll bring all the parts over, so I'll go ahead and do some opposite operations. Or I could go ahead and multiply here. See, if I went ahead and cross-multiplied, we'd be left with 4y squared equals negative 20y plus, and then 4 times 4 is 16, and makes 96. And so if I bring these two terms over, I get 4y squared plus 20y minus 96 equals 0. So you see, I'm going to go ahead and divide by the 4 now. You see, if I divide by the 4, I'll get rid of those 4's. And I'm just left back at y squared plus 5y minus 24. So you can see how I just got rid of those 4's by multiplying first. I have them all in there, moving everything over, and then I divided them out and I got rid of them. So now I'm going to go ahead and factor. So I end up with a y plus 8 and a y minus 3. So when I go ahead and solve using the zero product property, you see how you're getting negative 8 and positive 3. The negative 8's maybe a problem. Maybe it's the positive 3. Let's check it out. So, or maybe both of them are fine. So when I plug them in, negative 8 I'll try first. And when I put in the negative 8, it makes a opposite of a negative, so it makes a positive. So that makes 4. And on the other part, if I plug in the negative 8 in for this y, I get a positive 40 plus 24 divided by 4. And then I've got to take the square root of that. So this makes 64 divided by 4 makes 16. And the square root of 16 is 4. So that one does check out. So negative 8 is a good number. The 3, though, when I plug that in, I get negative 3 over 2. And that's a problem right there. So it doesn't matter what number we have in here. Negative 5 times negative 3 plus 24 divided by 4. That doesn't matter because, look, you've got a radical equaling a negative. You can't have that. That's extraneous. And so we've got an answer that does not work. So we're going to go ahead and cross out the positive 3, though, and keep the negative 8. So that is our answer. So those are types of problems that you're going to see on tonight's assignment. Good luck.